Today I'm going to be showing some of the differences between round and square rail, some of the disadvantages and advantages to each product line, and when you would choose one or use it for your specific design. First, you want to figure out what your design application limits are. So what's your load, what's your speed, what is it going to be mounted to, what's the configuration, what's the length. These are all parameters that are going to help you pick which the right fit is going to be. In this case, we are going to be showing how the deflection characteristics vary from round rail to square rail. One advantage square rail has over round rail is because it's much more stiff, it'll deflect a lot less once a load is actually applied. We're actually going to torque down on this force gauge, which is going to apply a load to the rail. We can see how much load we're applying here on the gauge, and then we're going to read on this indicator on the side how much the entire unit is deflecting. So we're going to load it up to 320 pounds. We're comparing, as we did over here, roughly same size rails. You can see that the size of the actual rail is similar between the two. We can see the total overall envelope of the square rail is smaller than this. So even in this case, we have to use a standoff to be able to fit the square rail in. So another advantage of the square rail is it has a smaller envelope size than round rail, typically. Apply a 320-pound load to this rail. What this shows is that the deflection characteristics are much better in the square rail versus the round rail. So that means in your system, you can apply more load to the square rail and expect less deflection out of the total system than you can with the round rail. So this is what we call the misalignment rig. One big problem we run into with users is they'll spec in the square rail type instead of a round rail, when really the round rail would have been more advantageous because round rail is inherently, for the most part, self-aligning. And so it's much easier to install. And what we're going to show here is some of the differences you'll find in the push force required to move your bearing. First we'll start with the round rail. Push it. Okay, so the peak force is 0.14 pounds. So that's very low. You can see that this moves very easily. So compare that to a square rail, peak force of 2.08. So profile rail bearings are not self-aligning, so usually have a little bit more resistance. Also, they're also commonly preloaded, which is the case in both of these bearings. So that's in the steady state. But say you have, like many applications, a base that is less than perfectly flat. And so we simulate this by turning this lead screw. We're torquing it a little bit, and so that's imposing a little warp here. You can almost even see it, it'll kind of rock now. So now you can see the round rail moves still fairly easily. The square rail really locks up. And so we'll see what the push force differential is now. Now we're up to 0.84, so an increase of 0.7. Even hard to get it going. There, almost 7 pounds now just to push the profile rail. If there was even more deformation in this base, you couldn't even move this at all. It would completely seize. So what this illustrates is that depending on what your installation requirements are and what your base is like, it's really going to help drive you towards using a square rail versus a round rail.